So sketching angles in standard position. You guys are going to learn how to sketch angles in standard position. First off, what is standard position? Standard and angles in standard position if the vertex of the angle is located at the origin and the initial side is on the positive x-axis. So what that looks like is essentially this. You have the angle that you are drawing, representing. Its vertex is at the origin, and then one of its sides is fixed to the positive x-axis. That means it is not going to move or change or be anywhere else but on the positive x-axis. This is known as the initial. This is known as the initial side of your angle. Now, the other side that creates your angle is called your terminal side. And your terminal side is the side that moves. It's the side that creates the angle with the initial side, okay? So this is known as the terminal side. And it could be in any quadrant. It could be in the second quadrant, third quadrant, first quadrant, fourth quadrant. It could be anywhere. But this is the side that's going to basically determine the size of your angle, okay? An angle is a quadrantal angle. We talked about this before midterms, but an angle is a quadrantal angle if the terminal side lies on one of the axes. Okay, we had talked about this before. So if you have another XY plane, again, your initial side is on the positive x-axis always. But then your terminal side is going to actually be on one of the axes. Like this, like so. That's a quadrantal angle. Now, how the actual angle measures are formed depends on which direction you move the terminal side. If you go counterclockwise with your terminal side, okay? So let's say you have your initial side on the positive x-axis and then your terminal side on the positive x-axis, and you decide to go counterclockwise, okay? You create a positive angle if you go counterclockwise. So from your initial side, going counterclockwise, you create a positive angle. So something like this would be 130 degrees. That gray arrow that I drew, that is important because one, it tells you which direction we turned the terminal side, and of course, which angle we're creating, whether it's going to be a positive or a negative one. So if you go counterclockwise, you're creating a positive angle. If you go just normal clockwise, then you are creating a negative angle. Okay, you're creating a negative angle. So again, starting from my initial side, going clockwise, we create a negative angle. And using a little bit of intuition, how many degrees would you say this is? 90. But since I went clockwise, it would be negative 90 degrees. So the same way you would go if you were going counterclockwise, you know, this one would be 90. This one over here would be how many degrees? 180. This one would be 270. This one would be 360. If I'm going in the counterclockwise fashion, that's also why the quadrants are labeled that way, because it creates a positive angle when you go counterclockwise. But when you go clockwise, now you're going in the negative direction. So this is negative 90 degrees. This is negative 180. This is negative 270. And then of course, this is negative 360, okay? But just because I've gone a full circle, I can keep turning my terminal side. So if I wanted to, I can keep going around and around and around and around to create larger angles, positive and negative. Those types of angles are called coterminal angles. Coterminal angles are two angles that have the same initial side and terminal sides, but different angle measures. That's what it means to be coterminal. So they have the same initial side, the same terminal side, but different angle measures. Here are a few examples. They're already drawn for you, so you're really gonna have to follow me when I'm like kind of color coding here. Remember, our initial side is always fixed to the positive x-axis, and I used green on the last slide, so I'm gonna stay consistent and use green again. My terminal side, as you can see, is in the first quadrant. Now, if I go counterclockwise, I create a positive angle or a negative angle. If I go counterclockwise, a positive angle. So one of the angles that I could create is a 60-degree angle. That is going from that initial side, going up just 60 degrees. That's one angle. But another angle that has the same initial side, but a different terminal side, could be negative 300 degrees. And that's because I go, instead of counterclockwise, we go clockwise and in the same position. Okay, so I'll do that again. If I start at the initial side and I go clockwise, I'm at 90 degrees, 180 degrees, 270 degrees, and then the remaining 30 degrees, which will put me at negative 300 degrees. Okay. I could also turn it multiple times passing the initial side. Okay. So if I start at the initial side and I go one time around, how many degrees is that? 360. But if I keep turning my terminal side again, that's another 360 degrees, which is how much? 720. So then if I end still back at my terminal side, I've gone 780 degrees because I've gone 360 twice, but I ended up at the same terminal side. 60 degrees, negative 300 degrees, and 780 degrees are examples of coterminal angles. Now, of course, there's infinitely many coterminal angles, okay? I just have to keep turning around and around in either direction. There's infinitely many, okay? But for 60 specifically, negative 300 is a coterminal angle, 780 is a coterminal angle, and I can even find other ones, okay? The same thing works with radians, okay? The same thing works with radians. I have my initial side on the positive x-axis. I have my terminal side somewhere to anywhere really. And then whether I go counterclockwise to make a positive angle or clockwise to make a negative angle, they are two coterminal. So here's an example. This is 7 pi over 4. If I go in the counterclockwise direction. But if I go in the clockwise direction, that's negative pi over 4. These two are examples of coterminal angles as well. They're just in radians. So how do you determine coterminal angles? It's very simple. All you do is you either add or subtract multiples of 360 degrees or multiples of 2 pi. 360 degrees, of course, if your angle originally given to you is a degree, and then 2 pi if your angle given to you is a radian. Okay? So let's practice. If I gave you 50 degrees, and I asked you to give me 2 positive and 2 negative coterminal angles. All you do is you would take 50 degrees and you would add 360 degrees to it. That means I'm going clockwise or counterclockwise? Counterclockwise. I'm going counterclockwise. So originally, this right here was 50 degrees. Now I'm adding 360 more degrees to that. So that's one time around and then back here. What's 50 plus 360?
410.
So 410 is an example of a positive coterminal angle. If I wanted to find another positive coterminal angle, I would just continue to add 360 again. So what's 410 plus 360?
70.
That would be the angle if I went around how many times? Twice. So 1, 2, 3. That would be 770. And the number of rings, like me drawing this, that's how you would represent these different coterminal angles. We'll work on sketching more on Friday, but this is how we find them. Same thing. If I wanted to find two negative angles, I would subtract 360. So what's 50 minus 360? Negative 310. So that's one answer. And then I'll subtract 360 again to get another negative coterminal angle.
Negative 70.
That's how we do it for degrees. I'll show you a radian one in a second.
I mean, will it always be like the pattern where it's like just 100 off?
Oh no, that it just happened to be
That just happens?
the angle I shows. Yeah. Let's look at a radian. Let's take a simple one, like pi over 2. Pi over 2 as a radian corresponds to 90 degrees, okay? But you don't want to sit there and try to convert 90 degrees, find coterminal angles for 90 degrees, then reconvert those back to radian. If your original problem given to you is a radian, you want to produce a radian coterminal angle. So now we're going to add, instead of 360, we need to add 2 pi. But in order to add a fraction to a whole number, we need a what? Common denominator. So pi over 2 plus what pi over 2 gives me 2 pi. So what's pi over 2 plus 4 pi over 2? And 5 pi over 2 would be a positive coterminal angle to pi over 2. Getting tongue-tied here. So let's look at that. Here is your initial side. Pi over 2 is located here because it corresponds to 90 degrees. So this would be pi over 2. But if I wrap it around one full time, this would be 5 pi over 2. And I just keep adding. I just keep adding another 2 pi to get another coterminal angle. Well, not 2 pi, what is it really? 4 pi over 2, so I can have common denominators. And there's another one. I would subtract if I wanted to find a negative one. So what's pi over 2 minus 4 pi over 2? And there's a negative coterminal angle, okay? And that's how you find coterminal angles. There's in standard position. Counterclockwise is positive, clockwise is negative. We'll practice more on the drawing aspect of it, but I'm hoping you guys at least were able to understand and follow me when I was talking about it's the exact same initial, exact same terminal. We're just turning that terminal side multiple times to get these other coterminal angles.